Hi, everyone. My name is Ahsan Ali. I am an applied scientist at Generative AI Innovation Center at AWS. Today, I'm going to be talking about 10 of the lessons from the field, which we gathered regarding developing production-ready solutions on generative AI. So according to EY, almost 63% of applications that are developed right now by companies which generate billion dollars every year are losing $1 million because of the AI failures. And similarly, if you look at another survey by McKinsey, almost every company that is generating AI applications are rated score of 2 out of 4 in terms of AI maturity. So there's a lot of organizations that are not yet mature, yet they're developing a lot of AI applications. So why are these bottlenecks and why are these companies facing these challenges? Because it's not because of technical difficulties, it's majority of the time because of the organizational culture and how they are approaching these solutions. So today in this particular talk, we will be talking about how we can address these challenges, what are these challenges, and how we are addressing these challenges as well. So before we dive deep into our 10 lessons we are learning at Generative AI Innovation Center, let's talk about how, as a Generative AI Innovation Center at AWS, we operate and how we are helping our customers. Also, how we are learning these lessons. First of all, AWS Generative AI Innovation Center is an investment program by AWS where we are helping our customers develop AI applications. This particular organization is a combination of applied scientists, data engineers, machine learning engineers, and strategists. So whenever a company or an organization these are usually large AWS customers that have business challenges they want to address through generative AI, be it increasing their revenue, maybe improve their overall processes, increase their productivity, or help their customers gain a little bit more value out of entire use case. So that's basically what we are trying to address here. So we bring in our strategists to work with the executive directors or C-suite from the customers and then help them identify a particular use case through which they can increase the impact of their organization. Once the strategists identify a particular use case, then we come up with a strategy, specifically go-to-market strategy of their AI product. And after that, we conduct a workshop through which we can identify that particular use case, what data should we use, what should be the specific parameters, or what should be a particular KPI that we would like to optimize through development. And then we bring in scientists, applied scientists, data scientists, and engineers to develop these solutions. So in past 3 years, we have helped hundreds of different customers develop hundreds of different use cases. And today, what I'm going to be sharing in this particular presentation, lessons we learned through this development process as well. So the first and foremost, what we have learned so far in our development process is majority of the time when a use case fails or maybe customer use case that doesn't go into production is because of the evaluation metrics. Evaluating generative AI applications is much harder than evaluating responses generated by humans because when you are developing generative AI applications, the responses are not really static, they are dynamic. And they can vary from maybe different angles. Maybe you want to make sure that your responses are aligned with your brand. You want to make sure that responses are truthful, make sure that your responses are accurate. All of these are various challenges that humans cannot verify individually. So how are we helping our customers? First of all, across the industry, one of the paradigms that's getting a lot of popularity right now is model as a judge. So where we are automating this entire process through which models are evaluating the responses generated by the LLMs so that we make sure the responses are accurate. But one of the key things we need to understand is we just cannot just rely on the LLM as judge response, because how are we going to evaluate these evaluators? Because if we are just relying on the LLMs for evaluating the responses, eventually there is still loopholes there where we can either lose our customer trust, we can generate inaccurate responses, hallucinated responses that becoming a major hurdle in putting the solution into production. So how do we work usually with the customers to make sure that we have robust evaluation mechanisms? This morning, we heard from our keynote speaker that how they are evaluating at Anthropic to evaluate the responses generated especially for coding assistants as well. So similarly, this particular use case we are describing here is generic, not for specific use case. So first of all, we jump into the solution. We identify a subject matter expert from a particular organization we work with. so that we understand what are the day-to-day operations, how do they work, and what are the key outputs, what good looks like from their perspective, to understand if we are generating the right responses. And we typically ask our customers to come up with at least a few good examples that can we utilize further to tune the LLM as a judge and then evaluate the model responses as well. So what we do is like we first of all evaluate the responses using LLM as a judge, and then we compare that with the human evaluated responses. We compare those responses, and then we make sure that the human as a judge responses are aligned with LLM as a judge responses by through prompt engineering, by few short examples, and other aspects of the solution as well. Once we have that, we also make sure that we have few examples so that we can utilize these examples as the models are updating, because LLMs are updating every 6 months. We do not want to just rely on one-time prompting and make sure that it scales as we change the model responses, as we change the maybe prompts, make sure that the responses are accurate and according to our customers' needs and requirements as well. So combining LLM as a judge plus subject matter experts, human judge evaluators, we come up with a more robust strategy where we can evaluate the models at scale as well. So that's the first lesson. You cannot just rely on LLM as a judge, as a response for evaluating the models. To scale your applications, robustness, accuracy, and factual accuracy, you want to make sure that your subject matter expert are involved in the evaluation mechanism. So that's the first lesson we have learned so far in this particular case. The second one is a lot of the times organizations do not just fail because they are not building fast enough. Sometimes what happens is like organizations are failing because they are moving too fast. Usually what happens is like a customer comes up with a problem statement where they would like to just go from 0 to 100 in just one use case. That's not the right approach from our perspective. The reason being, when you are going too fast, you basically miss a lot of problems in the middle. For example, what we saw earlier in the evaluation mechanisms, you see a lot of these problems along the way. So our approach, instead of going too fast, we recommend our customers to build a one use case. We apply crawl, walk, and run kind of approach, where we build a simple use case to educate our customers how this technology could be utilized in one particular organization. And then we ask our customers to look across their entire organization to see what other use cases they can build using this technology. And that helps them scale their impact as well. For example, I can give you an example of one of the customers we worked recently, which is like PGA Tour, which is a golf organization that generates a lot of data on the golf course, where they can collect information about their players, their shots, their seasonal performance, their yearly performance, and also they have structured data, unstructured data, their information about the golf courses. And all of this information sets in different information silos or data silos. So initially, they wanted to build a system that collects all of this information, that provides insights about their systems to either their media team, their data analysts, their maybe data scientists, so they can utilize this information to inform their players how they're performing, where their key weaknesses are, and how their operations are failing. But when we start implementing the solution, we realized that their data was not actually ready for production-ready environments. So initially, we started by building simply a chatbot, which consumed almost like 1,000 PDF documents. And then we made sure that our responses are accurate for those particular chatbots. So essentially, like what they wanted to make sure in the beginning was the responses are accurate and it's aligned with their requirements. Because if a customer who is sitting in a bar and asking information about a player and the information is not accurate, that damages PGA Tour's reputation. Also, their players are their brand ambassadors. And if the chatbot says something negative about their players, that impacts PGA Tour's reputation as well. So they want to make sure when their responses are generated, that's according to their policy, according to their brand, and it's factually correct as well. So with this simple chatbot, we showed them how this technology functions. And over the period of time, within 6 months, the organization utilized this particular framework to scale their generative applications and went from just one use case to 36 use cases. And in the final version, where they were utilizing generative AI to generate on-the-fly automated commentary, which consumed all these data silos within their organizations to highlight if a particular shot was really important in a golf game, and then send that information to personalized information or notifications to their fans so they can see each and individual player's performance in a particular game. Usually that's not really possible, because in a particular golf game that runs for 4 days for each event, there are like 48 different players playing at the same time. And usually with what we see in a TV is just like one particular player or maybe top 5, 10, 15 players that are performing really well. So they want to show all of these information by push notifications to their customers or their users or their fans about their specific player, how they're performing, what shot is very important so that they get contextual information about a particular game as well. And another use case they built was push articles about their players as well. Earlier, they would take almost like half a day to generate articles for each player, how they performed at the end of the day. But using generative AI, they shortened this entire process from hours to just a couple of seconds. And instead of utilizing human writers, all of this was done by using AI that expedited their entire process, increased their productivity, reduced their labor intensity as well. So that's another lesson, that start simple and apply crawl, walk, and run approach as well. And another particular graph, this particular graph shows how different organizations are impacted by this approach as well. So if you look at this 86% graph, almost like all the organizations that fail to capture the information is because they do not have visibility of the data. Where is the data coming from and how is that data utilized? And that basically causes a lot of hallucination problems in model applications as well. So nowadays, like a lot of applications and organizations wants to build agents most of the time. But not all applications needs agents, for example, because agents are dynamic. When you build an agent, you are not 100% sure what can be the response of a model, because you are making dynamic decisions, you are utilizing tools to generate outputs, and that could result in dynamic outputs as well. And that increases the overall accuracy of your responses. And also it can result in inaccurate responses. And if one of these decisions throughout your agent chain or your tool chain is accurate, particular inaccurate information can follow through your entire chain and result in a lot of errors throughout your responses. So that's why you need to make a decision about which one of these applications should utilize a pipeline and which one of these should be utilizing agents. So the third lesson here is to ideally, you want to build simple solutions first, identify and make sure that each of these pipelines or each of these tools are generating accurate information, and then combine all of these as you go and then verify the information so that end-to-end responses are accurate. I was having a conversation earlier with one of the folks here, and they were specifically asking about when your applications have a lot of tools and a lot of agents, how would you typically evaluate the responses? So that's exactly what the technique should be, that you independently identify and evaluate each of these agents or each of these tools so that when you combine all of them, eventually the end-to-end responses are accurate and you can easily debug your system where exactly the problem lies. And that basically becomes your recipe for developing complex agentic solutions as well. Going forward, as you mentioned, like you want to make sure that your responses are accurate. How do you do that? So you need to be able to trace your responses. If a particular agent is using a particular tool, you want to make sure which tool was used and each of the tools, like how and where the data is utilized and how the data is utilized. And you have to have the traces of all of these. We listened to earlier talk about the traces and looking at different problems or errors in your entire application. So there is another application or another way you have to make sure that you're tracing your information flow throughout your agentic system to make sure that it's accurate. Earlier, we were taking the approach of trust all and verify the information. But from last year, I think Replit had an incident in July where one of the AI agents basically deleted an entire table. And eventually when we asked, like the person asked to fix the problem, the agent said it cannot be fixed. So that basically shows that we need to have clear boundaries of what an agent can do. And we should have specific governance to make sure that the AI is not taking actions on our behalf, which can be catastrophic down the stream as well. That takes us to our fifth lesson, which is hallucinations. So when we talk about hallucinations, it's a blanket term for multiple hallucination types. There are like various hallucinations that a model can face. The first one is unknowns. Like usually what happens is if the model does not know any information, it usually relies on next token prediction and it tries to come up with an answer based on the user input. And if the model doesn't know the answer, it based on its pre-training, it will come up with an answer. That could be one form of hallucination. The other form of hallucination is the semantic confusion. If the embeddings of the two inputs are similar, the model can confuse that, and that can also result in another hallucination as well. And mathematical limitations of a model's performance is also well known, that most of the models are not really capable of doing mathematical operations. That could be another form of hallucination. So there are like 4 or 5 different kind of hallucinations as well. I'm not going to go into all of the details, but knowing all of these different types during your execution is really helpful, so that you can address these either through prompt engineering, either through providing the right information, or either putting right guardrails at the right place so that the model generates the right responses as well. And one of the other things which is really critical when you are building these applications is in what sequence you want to optimize your applications. Oftentimes, organizations try to, especially enterprise application builders, try to improve the speed or reduce the cost because they are going towards improving the cost of the system. But that's not the right frameworks to evaluate the responses, because if a particular application, especially production-ready application, that's only 80% of the accurate and 20% of the time false, that's not going to be a good application. So that's why the first step when you are evaluating AI applications is that accuracy first, and then you go towards the cost optimization, and you go towards the speed enhancement as well. Because eventually what you want to do at the end of the day is your accuracy, your models or your applications are generating accurate or factually correct answers or information. Otherwise, if you have a very optimal, cost optimal, very fast application that generates garbage, eventually nobody's going to use, and that's going to erode trust, and nobody's going to engage with your application. So it's very important that we focus on the right frameworks in the right order to get the right responses at the end of the day as well. And another key aspect of this particular paradigm is AI is evolving really fast, and there are a lot of different players in the market right now. We have new models every day, and we have new organizations that are coming with models as well. This particular graphs are showing the AI adoptions of different or market share of different organizations right now. You can see in 2023, 50% of the market share was captured by almost OpenAI. And now in 2025, almost 32% of market share is captured by Anthropic, and OpenAI has reduced from 50% to 25%. And that basically tells us a story that we should not be tying our applications, or we should not be locking ourselves into a specific framework, specific AI tool, or specific AI model, because these models can change. And we have seen in recent past that every 6 months, a new model comes in and the previous models are depreciated. So that means if you are optimizing your application for one particular model or one particular framework, you may lose some of your value capture position as well. So that make sure that when you are developing these solutions, you're not locking yourself into particular application, a particular framework, or a particular model. You want to make sure that your application is evolving with different models and different applications as well. Essentially, what you want to do is you want to build a vendor agnostic interface that from day one. Maybe you would like to utilize multiple models, as earlier presenter mentioned, that you wanted to use a model that is, sometimes you want to have a bigger model that captures more complex solutions, and then smaller models that can do simpler tasks, such as maybe classification of segments or maybe extraction of information. So you want to use multiple of these models to make sure that your applications are robust and model agnostic or vendor agnostics as well. And majority of the time, when we go develop these solutions, we do not think about the business impact. So I think this should be one of the core values when we are developing these solutions, what exactly we are solving for using our generative AI applications. Just because generative AI is available and we can solve a solution or we can build a solution, it doesn't mean that we should build a solution. We should think about from business outcomes, how and where we can utilize generative AI solutions. For example, recently I worked with one of the companies that does identifications of actions in a video. So what this means is that they are currently using a traditional ML pipeline, which looks at a video stream and identifies different actions in a video game or any game, such as soccer, basketball. They want to move from that particular application to a VLM-based application to identify the solutions. But their existing pipeline is much cheaper, much faster compared to VLMs, because VLMs are not at the same place where you can identify these actions more robust. So that is a typical example of, just because VLMs or these new LLMs are sophisticated and generates better answers or maybe comparable answers, you need to develop these solutions. But you have to think about if it generates the right outcome for you or not. Another key aspect, we have listened about this in the beginning today in the morning as well, that you want to have a feedback loop from your users, how they are utilizing the outcome. In the morning, we listened from our keynote speaker that how they are using feedback loops from the users about how the model is performing, how the application is performing. That's really important as well. You want to capture the value so that you, from the user, and get the feedback into your LLMs or your applications so that you can auto improve your systems. And that is the trend we are seeing in the industry as well. And finally, you have to have a quality control culture as well. It's not just a tooling aspect. You have to get feedback from your customers, your users, your employees to understand how each one of these different stakeholders are using your applications so that you are optimizing your application in the long run as well. And you have to have a quality control system, such as we heard from previous speakers about. We would like to have some sort of visualization that tells us about the token consumption, the accuracy, and overall performance of your applications so that we can optimally deploy these solutions and have a quality check and controls so that we can optimize overall solution of the system as well. So if I have to overall conclude my talk, I would divide my key takeaways into 4 different aspects. The first one is humility. So while we are going towards productivity and we believe that AI systems can do a lot of things, we still need human subject matter experts to make sure that our systems are following the right answers and accurate and human in the loop systems so that we can get right answers. And then the next thing is when we are building solutions, we need to think about business outcomes and if our systems are generating right value and if our use cases are accurate or if our use cases are following business impact as well. And iterations. When we are building, we cannot just build one time and be done with it because these applications are evolving fast. We need to iterate over our solutions. We need to integrate new systems. And when we build these solutions, we have to think about how we can improve the solution in the long run when a new model comes out, when a new frameworks come out, how we can integrate that into system as well. And majority of the companies that are winning in the AI right now they are not like the most sophisticated system, but they have built the systems or AI applications thinking from the user's perspective, how we are helping our users and how we are generating or creating value for our systems as well. So overall, that's key takeaways from our learning so far. And I hope these are useful for you as well. Thank you so much.
Tried to optimize for 4.0 and then 5 came out and then tried to optimize for 5 and 5.1, then 5.2. How do you anticipate what's going to come next? Like, how do you shoot for where the ball's going to be, I guess?
That's a very tough problem to have, right? So right now, there is not a single solution that can address that problem. But ideally, what we advise our customers or what we are seeing in the industry is that you have some sort of a benchmark specific to your application. And when a new model comes in, you just test that benchmark and see where you lie. And that's where the automated evaluation mechanisms come into play. And then see how you can optimize it. And then you can have an automated mechanism of optimizing your prompts based on the new model. So you have some sort of feedback mechanism that evaluates your benchmark and feedbacks that to your new model and then optimize your prompt as well. So it's some sort of prompt optimization model that can then further be utilized to maybe reprompt your application based on new models, if that makes sense.
But then you're constantly revising the system. So the new model comes out, you're revising the prompt, which revises the actual flow of the system. So it's like you're building the system from scratch every 4 to 6 months, almost.
Almost, yeah. That's the key challenge here. That's where we are at right now, based on the industry's pace.
Cool presentation. So when you started with the very simple use case, the chatbot, but it's a golf tournament and you're using sources from the internet, how do you ensure that the information will be politically correct and so on? You could have a confidence level. You could say, I'm 95% sure this is accurate and appropriate, but do you have mechanisms to be 100% sure?
So usually what we advise our customers is utilize, first of all, benchmarks. So in the case of the chatbot I gave you example, I asked our customers to come up with 100 different questions specifically for their use case. And then we evaluated the responses based on their specific outcomes and compared that with the generated outputs as well. So that's the first part. The second part is toxicity, maybe biases, or maybe making sure that your outputs are aligned with your brand's value. So you want to have, let's say, some sort of guardrails around your chatbots or your applications as well to make sure that your chatbots or your applications are according to your use case, They're not generating, for example, if you have a sports chatbot, it shouldn't be giving you like cooking recipes, for example. Right. So that's some of the guardrails you have to enforce, and you have to continuously, iteratively test your application to make sure that it's aligned with your use case.
And how are you enforcing that guardrail? LLM as judge or something? And even would you then want adversarial examples? So I'm asking about a player. There could be information on Reddit about that same player, which is their game and their personal life. And it can be pretty nuanced.
Exactly right. So you have to have adversarial examples in your data set to test the model's performance. If they generate, like, for example, in the case of the golf example, like Tiger Woods, somebody asked about Tiger Woods like problem.
Right.
So it's going to get some information from the internet, and it has been trained on that. So you want to make sure that don't say personal information from your chatbot, or you want to give them enough context from, let's say, your own repository, that if the information is available in this repository, generate the answers. Otherwise, don't say anything else. So you want to make sure that your information is limited to the information you want to present to your outcomes of the users.
One more question.
Hi, great presentation. I'd love to understand one thing specifically that you talked about over here, workflows and agent building. So that's like huge chaotic space out there, so many conversations around here. How do you ensure that the right business case for your client is solved and you provide them the minimalistic or an easier workflow? So A, how do you identify? And B, then how do you design that workflow that's not that complicated for someone who's not that tech forward?
So we have strategies in our teams. They have go-to-market strategies for different industry verticals. They work with the customer C-suite level leadership, and then understand their business, first of all, what they're trying to create value. And then based on that, we identify the use case that generates the most impact. Maybe generate more revenue, enhance their user experience, or maybe go to a new market completely that brings in new customers. So we look at different lenses before identifying a particular use case. And the second one is we bring in experts from our team, scientists, data scientists, machine learning engineers, who have worked across different industries and different verticals, and then rely on their expertise to develop these solutions. And when we hand over these solutions to customers, we give them detailed documentation about how should they apply these in or take the solution into production. So these are our approaches to make sure that our customers get most out of these engagements or these solutions. Makes sense. Thank you, folks.